Hello and welcome. We're going to talk in this chapter about network access. We're going to talk about some of the media that are used and some of the way that media works to carry signals throughout. This first section is just talking about physical layer communication in general and the types of connections that we use in making the communication happen. So the most common that we'll be dealing with would be Ethernet cable, as you see down here on the bottom, or wireless connections, which you might be using in your school or your home as well. Wireless has become a much bigger deal in the last decade as those protocols and the methods of controlling wireless communication have improved. So we do have wireless NICs on laptops, mobile devices, etc. And then we also had wired network interface cards. So where you plug the Ethernet cable in is the network interface card, or a NIC, and all of those NICs have their own burned-in MAC address that make them unique in the world. And as you read in the chapter, those NICs have addressing that makes them unique because half of the address is the manufacturer and then the other half of the address is unique within. Well, let's talk about the physical layer here. And the physical layer down here, that's where everything happens. And we talked about encapsulation earlier. That's where the ones and zeros are in frames actually moving across the media, be it fiber, wireless, or cable. This is the first layer of the OSI model, and an application always comes down to being encoded, and when it gets to the destination, that encoding gets torn apart to find the application data inside. Now, it's generally pulses of electrical signals or light signals or even microwave signals, depending on how it goes across. Ethernet is media independent, meaning that Ethernet traffic can travel on any of these at any time. Chances are every communication you have has multiple different types of multiple media getting the signal through. The standards taken care of down at the physical layer, and we say physical and half data link, go back to the hardware governed by the ISO and IATF, as we saw in the earlier chapter. The TCP is up above, but at the physical layer we just work about the standards for the cabling. Now the encoding that happens, how the ones and zeros get carried, depends on the medium. So in the modulation, we have sine waves, and they can go up and down for a 1 and a 0, with depending on where they are on the scale. That could be the 1 or the 0, the absence of energy or the presence of energy, the absence being a 0. Over here is Manchester encoding, and you can see here that it measures in the middle of the signal, wherever it is. If it's up in the middle of the signal, then it's a 1. And then it drops in the middle of the next signal, so it's a 0, and so on. So it measures in the middle of the encoding part, wherever it's gone to. And that's how Ethernet cables measure ones and zeros. So it's, again, the presence of energy with a 1 or the absence of it. And those patterns of energy are how all the data is carried and stored. And that happens within bandwidth. Now, I've been around a while, so I still remember when bits per second meant something. My first download, I could actually read the newspaper as it came across the computer, but that wouldn't happen now if you look at how many orders faster data travels now. So bits per second has gone all the way up to terabits per second, which was unimaginable back in the day. So the throughput of bits per second, the megabits per second, download and upload, that's the throughput. All right. And there's, the theory and the practical. You'll hear a term called goodput in the chapter that is actually data you can use. So bandwidth doesn't always mean what's really useful to you when you get it. So these physical media need connectors on a router. This is the back of a Cisco router. And we mostly have fast Ethernet ports for this one right here. But this is the DSL interface that might come in from the phone company. Instead of needing a DSL modem, you would just plug it right into here because that modem is now internalized, like an onboard modem in a PC. Here's the console cables, the management ports. Each of these are what you would use to go in and look at the router for the configuration. You would use your own computer's mouse and keyboard and monitor to get inside for a look. Then we have gigabit Ethernet interfaces, much faster, and then a fast Ethernet port, and then we have some USB connectors as well. So, in network media, we have copper cabling. Again, we have purely digital, measuring the ones and zeros. Now, we have to be careful how copper cabling is handled. If it's next to some kind of interference, that signal can be degraded, and then the computer won't know what's a 1 and what's a 0. I once worked in a place where that was a problem. Every afternoon, a janitor would plug his vacuum cleaner into a wiring closet outlet and start vacuuming, and everybody's computers would go fuzzy. And it took a while to figure out that his motors were degrading the signals that everybody was using. So they have to be in good shape to work. So the copper media we use is called cable. There's different types though. There's unshielded twisted pair, which is 99% of what we see in our offices when you buy an Ethernet cable. For special circumstances, there's shielded twisted pair, so if your cable does have to go through an environment that is electrically noisy and has some interference, that shield can protect it. And then there's coax cable that's also wrapped in certain ways to protect the signals as well. Now, notice that these are all twisted at different rates. If you untwist these cables, each pair of cable would be a different length than the other. So the twists are different because there's a signal coming across, and then all of those signals would leak over to each other, but the twists in the pair keep that signal from happening. So this is in an untwisted pair of cable. You have the outer jacket, and then the twisted pairs inside, 4 pair of twisted pairs with different colors. And then we use those colors to determine where they go in the plugs. For shielded twisted pair, there's a braided or foil shield that keeps those signals out, and then they still have to twist the pairs inside because the signals would come from each other. But this shield protects from electrical motors. Coax cable used to be very strong. Now most of the cable we see just plugs into the TV cables, and this was a different type of cable than that. The thin net, it was called, carried signals, but I haven't seen any thin net for quite a while. So the barrel nut connectors are how they were attached at the end, but there's, again, that's getting a little bit rare. Now, as far as media safety, you have to keep your data and electrical away from each other because the electrical power will interfere with the cable signals. All right, so that's just a given. You put them on different panels in the workrooms or different rooms altogether. And it has to be grounded properly. Earth ground is different in different places. And one of the advantages of fiber over copper is that it's not really subject to electrical interference and lightning strikes and things like that. But that's why